In this example, we're going to look at a complete neutralization of an acid with a base. This example asks what volume of a 0.1 molar hydrochloric acid solution is needed to completely neutralize 25 milliliters of a 0.350 molar sodium hydroxide solution. So, handy pen, we're trying to find a volume. We're given a concentration of HCl. We're given a volume and a concentration of NaOH. So the first thing to do whenever you have a word problem is to write a balanced equation. So the first thing that we're going to look at for this neutralization reaction is to write the equation. This equation is hydrochloric acid, which, think about what state of matter that should be. Okay, it should be aqueous, plus sodium hydroxide, also should be aqueous. Think about why those two things should be aqueous. If you can't remember, look back at some of the other videos that I went through. It yields sodium chloride and water. Sodium chloride is aqueous, water is a liquid. So this is the molecular equation. Again, think about what the net ionic equation of this would be. This is the molecular equation, though, for this complete neutralization reaction. Now, when the problem says that it completely neutralizes, that means that moles of acid equals moles of base. So this is extremely important when we talk about complete neutralization reactions, because this means that all of the moles of base that are neutralized by the same amount of acid, assuming it's a 1-to-1 ratio. So the question is then, how many moles of sodium hydroxide do we neutralize in this example, right? How many moles do we neutralize? So what we need to do is take the given information and figure out how many moles we neutralize. Well, we know the volume and we know the concentration of sodium hydroxide. So we can determine moles from that given information. So I know that I start with 25 milliliters, I convert to liters, right, so my milliliters cancel. Now I'm at liters. I use my molarity to get to moles. So remember, if you have a given, you always use mass or volume as a given, and then use the molarity as a conversion factor. And so we use this molarity to get to moles, and we find that we neutralize 8.75 times 10 to the negative third moles of sodium hydroxide. So that's how many moles of NaOH we use in this process. Since hydrochloric acid and sodium hydroxide are 1-to-1, right, from the balanced equation it's a 1-to-1 ratio, that means that we need the same number of moles of hydrochloric acid for this to be a complete neutralization. So what we can do then is we can take our moles of HCl, we know our concentration of HCl from the given problem, we can find volume. So I take my moles of HCl, I use my molarity for every 0.10 moles, I have 1 liter of solution, and I find that I then need 0.0875 liters of HCl. So from this problem, the complete neutralization, we can figure out how many moles of HCl we need and then use the concentration, or instead of setting it up like dimensional analysis, use the concentration formula, use the molarity formula to determine the volume of HCl that we would then need.